yesterday, would you agree that we have cosine sum and a cosine difference identity? We have a sine sum and difference identity. Yes? And we had one small example of when we might use that. Okay, this is from yesterday. Could we find more? Are there other things that we might want? What if I ask you what is, let's do sine this time. You have all the equations. Do we need to write them down again? No. Do you need to write them down again? No. No. You got them? You know them off the top of your head?
No.
My other class, I made write things 25 times, and they're still struggling to get it in their head. You need to memorize it. It's not something you're going to write on your plate.
Can you use those
Right here.
if you want to find the unknown side of a triangle?
No. I mean, you use the Pythagorean theorem if you want to find the unknown side of a right triangle. We've already done that. We already have a way to find those.
Yeah, I know what I said. Would you ever have this?
I'm going to ask you some things like, what is sine 75 degrees? Okay, so is there multiple ways to do this? Emily just told me one.
Wait, how can I know something?
45.
So 45 and 30. So could we rewrite this as sine 45 plus 30?
Yes.
Yes.
And that's A
And that's A and
and that's B.
that's B. You're writing it down. The more you write, the better you will do. So what is our formula? How are we going to plug this in? If 45 is our A, 30 is our B.
45 times cosine 30. No.
Uh-huh.
No. Yeah. Cosine 30 plus sine. Cosine 45 times 30.
Okay. So what are we doing to find? What is sine 75? We've broken it down. What do we have to know now? What those are. What do I need to do to find what those are? They're triangles. These triangles are not ever going away. What's the side of my isosceles triangle? What about the other one? You need to be able to reproduce those triangles at any moment. We've been doing triangles for about 2 full quarters now, at least. So what is sine 45? Square root of 2 over 2, cosine 30. Square root of 3 over 2. What about cosine 45? What about sine 30? 1/2. So we're multiplying fractions. How do we multiply fractions? Square root of 2 over 2 times square root of 3 over 2. Square root of 6 over 4. Square root of 2 over 2 times 1/2. If we want to combine those, what can we do? They already have common denominators. There, and I wrote 6 again. Square root of 2 over 4. That's your final answer. That is what sine 75 degrees is. Does that look a little familiar? Shall I go back?
What was sine?
Oh,
Same sine.
go back for a second.
Was that what?
It's the same as sine 15.
Why in the world would they be the same answers?
Or
Why
it's
can't I not-
cosine 15,
Cosine 15 and sine 75.
They're co-functions.
Because they are co-functions. Isn't that lovely? We didn't even have to do anything to know. If we already knew cosine 15, sine 75 has to be the same thing. What about,
That was fun.
oh yes, transitions are great. So we've done 15. Then there's only so many that you can do because you can only combine things that you already know. So what if I wanted to find,
Was it like 15 and 75 are really like the only ones?
oh no, they're really not.
Well, I mean, they're not, but like this. Like what? Really,
Okay.
that's
So if you go bigger, so what are you going to use? You could use 90 and 30. Does anybody see anything different we could use?
16.
You could have used 60 and 60.
That's gonna be easier.
Yes, it is. So we could have used cosine 90 plus 30. Or we could use cosine 60 plus 60. Guess what? They will both give us the exact same answer. Okay?
It's gonna be something minus.
So cosine is a sum or an addition. So in your formula, what's your formula going to be? France, can you walk me through the formula?
The formula,
Yes.
cosine 60, sine 60.
Is that what cosine functions are? Did you not bring anything?
Oh.
I mean, I'm like, everybody else has got stuff out, writing down, they're looking at their formula. When we had a cosine function, did we start with a cosine sign? What was
No,
different about cosine? Because it was cosine, cosine. Then what's next?
Sine.
Minus, sine, sine. And we'll talk about, maybe tomorrow, what's special about this. What is cosine 60? Actually, not necessarily about 60, but what is cosine 60? 1/2. Could I say cosine 60 times cosine 60 is really cosine 60 squared?
It equals 1.
Could it be that?
No, it doesn't.
No.
Wait, yes, no. Sorry.
And then what is sine 60? Sine 60 is square root of 3 over 2. Could I say sine 60 times sine 60 is really sine 60 squared? Could we say that? Yeah. So what's a half squared? 1/4. What's the square root of 3 over 2 squared? 3/4. What's 1/4 minus 3/4?
Negative 1/2.
Negative 1/2. We actually got a number with that one. Does it make sense that it's negative? Cosine 120 degrees is in the second quadrant. So therefore, cosine has to be negative. Now, do you know another way to find cosine 120? You know 90 and 30, we could do that. This one actually falls as a reference angle. And when they're doing this, I will ask you to do it this way. So you can go back and check yourself. It's got a reference angle of 60 degrees. You're in the second quadrant. This one automatically turns out negative. It's not that hard. What time do we get out of here? 'Cause I've already 25. We have 5 more minutes.
So what happens if they give you like sine 17? How would
We're not going to do that right now.
not there yet?
No, we still have to be able to combine.
I want to beat it.
I
Yeah.
know.
No. I mean, ultimately, you're not going to be able to find an exact value. The best thing you can do is plug in your calculator.
We have all these mathematicians. We still can't figure out how to get an exact value.
Well, I'm sure somebody did. Somebody has, but they do not give it to us to teach to you. I don't know how to do it.
Fulfill my knowledge, you know.
You that you already have there, you just need somebody to spur it on into you.
Do you have like a little candy?
I have some mayonnaise in the closet, yes.
You cut yourself? No, I was hurt and it's like being rubbed on and it hurt. There's stuff in it and it's gross. It's itchy.
There's even some Neosporin.
Thank you. I
No.
always get one stain in it. It's always in the same spot.
Yes.
Sorry.
All right.
Thank you.
So, question: if we have a sign where the two angles are the same, could we have two angles that are the same? Could we? What's a? Could somebody tell me what's a plus a?
2a.
2a. So this is really a sine 2a. How's our long formula? Sine, it's going to be sine, cosine, right? So we have sine A, cosine A. Do we have a plus? Yes, we do. Sine A, cosine A. I know the book, the worksheet writes it cosine then sine, but it doesn't really matter which one is first because the commutative property of multiplication is amazing. So what is sine A cosine A plus sine A cosine A?
2 sine.
It's just two of the same thing. 2 sine A cosine A. We actually have another formula. This is called a double angle identity.
I mean, it is a formula, but it's kind of also just like reasoning of how you get that, right?
What do you mean? From here to here?
Yeah, like the
Yes.
double angle.
You can always go back to here and get down.
It's not like a whole new thing.
No. But they do stop and talk about it. Double angle identities. And later we'll talk about half angle identities. I know. Wonderful. So double angle identities, we're not ever going to talk about the subtraction. Because if we did a minus a, that's 0. What is sine of 0? 0. Right? So we're not going to do the subtraction one. But what about cosine a plus a? What is cosine a plus a? Okay, so you're going to tell me that cosine a minus. So I can rewrite that a plus a again as 2a. So how can I rewrite this one and we'll be done? What's cosine a times cosine a? What cosine
Cosine
times?
A squared minus sine A squared.
Cosine squared minus sine squared. So we have a formula. You have an equation, Pythagorean identity, yeah, that's weird. That's sine plus cosine is 1. But cosine minus sine is really cosine 2a. Okay?
What does that have a name?
It has a double angle identity also. Yeah. And you may go, class is short and over. Woo!